Okay, this is SOL A.4. This is a big one that includes a lot of different things, so feel free to skip to the part that you need. The student will solve multi-step linear and quadratic equations in two variables, including solving literal equations, justifying steps, so that's the one where you're using properties to justify the work that's being done, solving quadratic equations, solving linear equations, solving systems of linear equations, and then solving real-world problems involving all of that. Okay, first example is a literal equation. To find the volume of a pyramid, you use this formula. Which equation solves this formula for B? So remember, we're trying to get B by itself, so we want to move everything else over. If you have a fraction of 1/3, we're going to multiply by the reciprocal. Okay, and 3/1 is just 3. So I end up with 3v equals b times h, and divide by h on both sides. And that would be A. Okay, justifying properties. Which property of real numbers justifies going from step 3 to step 4? So step 3 to step 4. Remember, sometimes they're going to show you what they're doing, sometimes they're not. For this one, you have to think, how did they get from 45 to -9? Well, they had to have divided by -5 on both sides. So whenever it's whatever you do to one side, you do to the other. Remember that it's a property of equality, and it has to be division, so it's D. Solve the quadratic equation. So remember, we know tons of different ways to do this, whether you are graphing, quadratic formula, factoring, whatever you want to do. Just make sure that it's equal to 0 before you solve. So the first thing you have to do is add 8x to both sides. So we end up with 0 equals x squared plus 8x plus 15. This one will actually factor nicely into x plus 3, x plus 5. So then remember, if you set each side equal to 0, you get -3 and -5. And again, you also could have typed this into your calculator and graph it, and you'll see the same thing. Okay, the graph of f of x is shown. Identify each solution to f of x equals 0. This is almost sort of repetitive. Remember, a solution is the same thing as a 0. It's just saying, where is it equal to 0? Where is the output 0? So in the SOL, you're going to have you're just going to use your pointer, and when you move over a coordinate, it's going to plot a red dot. So if I clicked there, it would do a red dot. Now, you have to make sure you click the exact right spot. So this one is only asking you for solutions. So you should only click -5 and +1. Okay, I know sometimes it asks for the y-intercept. This one it's not, so do not click anything besides those 2 points. Okay, Michael was solving an equation. The last line of his work was 5 equals 7. Which statement best describes the solution to the equation he was solving? Remember, if you end up with a statement that is false, that has to be no solution. Okay, infinitely many solutions will happen if you end up with a true statement, so something like 7 equals 7. Here we're just solving the equation. Remember, if there's a fraction and the denominator will go nicely into these numbers, go ahead and distribute. So we're going to distribute that. So you get 4n plus 4 equals 22 minus 2n. And if you can't remember how to multiply that in your head, you can always type it in your calculator. Just make sure that you put the fraction in parentheses. Okay, now we want to get all the n's on the same side. So you get 6n plus 4 equals 22. Subtract 4, you get 6n equals 18. Divide by 6, and n equals 3. So it is A. And again, you could always plug that back in to make sure that it works and double check your solution. Okay, what is the solution to this equation? Go ahead and distribute 12. You get 12c plus 36 equals 12c plus 36. Right off the bat, you might realize that we're ending up with a true statement, so it's going to be infinitely many solutions, or all real numbers. If you forget and you start to solve, that's okay. Say I did that, then I would end up with 36 equals 36, which is still a true statement. So I know that if I get a true statement, remember back a couple, then that would be infinitely many solutions or all real numbers. Okay, from the list of ordered pairs, determine all possible pairs that are solutions of the linear equation y equals negative 2x plus 4. Okay, two ways you can do this. You can either plug the point into the equation and see if it's a true statement. If it is, you're going to click that one. Or you can look at the graph and kind of see, does it fall on the line? Because if it doesn't fall on the line, then it's not a solution. Okay, so 0, 4 is right there. That is on the line. Again, I could plug it in. Negative 2 times 0 is 0 plus 4 is 4, so I would definitely click that one. Positive 1, 2, 3, 2 does not fall on the line, so I wouldn't click that one. You could also plug it in. You get negative 6 plus 4, which is negative 2, not positive 2. Negative 3, 1, 2, 3, 1, 2, 3, 4, 5, 6 is there, just about there, and does not fall on the line. Again, I could plug it in, and I end up with a false statement. Negative 2, 8 does fall on the line, and again, I could double check. Negative 2 times negative 2 is positive 4. 4 plus 4 is 8. 1, 2 is right there. Negative 2 times 1 is negative 2, plus 4 is 2. That one works as well. And then 1, 2, 3, 4. 4 would be right there, so that one's not going to work. Okay, so you would have to click H, P, and T to get the entire question right. And that's just two different ways you can do it. Now, one thing I do not want you to confuse, when you see solutions of a linear equation, remember that's different than a quadratic equation, because solutions of a linear equation is any point that falls on the whole line. So it's going to have, infinitely many solutions. Whereas a quadratic, when we were talking about solutions, we were talking about where does it cross the x-axis. So for a linear equation, it's not just going to be the x-intercept. Okay, it's any point that falls on that line or makes that equation true. Okay, find the x value of the solution for the system of equations shown. Alright, so in this case, it's not really set up for any method right off the bat. But what we can do is, if we want to use elimination, we need to make sure that the variables are lined up. So to do that, I need to move 4x to the other side. So I end up with negative 4x minus 6y equals 2. Okay, and then I can just look at this system. And now that's going to work really, really well for elimination, because you have negative 4x and positive 4x. So remember, when they're opposite, I'm going to add. Negative 4x plus 4x is 0. Negative 6y plus 2y is minus 4y. And 2 plus 8 is 20. So we know y is negative 5. Now to get x, I want to plug it back in. So if I look at this one, might be easiest. Negative 6 times negative 5 is 30 equals 4x plus 2. Minus 2 is 28. Divide by 4, and x is 7. Okay, now what you could also do is take these system of equations and put both of them into slope-intercept form, which remember means getting y by itself. Graph them in your graphing calculator, and they are going to intersect at one exact point, and that is the solution to the system of equations. Would be the ordered pair 7, negative 5. Okay, one more example of a system of equations. In this case, you could either, they're already lined up, you are going to have to multiply because none of the variables have the same or opposite coefficients. So I could multiply the top one by 7 or -7 to get the y's to line up. Just to show you a different way, remember we also did substitution. Since y has a coefficient of 1, I'm just going to get it by itself. So if I subtract 2x from both sides, I get y equals -2x plus 6. And then what I can do is to take -2x plus 6 and plug it in for y into that equation. So then I get 3x minus 7 times -2x plus 6 equals 9. Now distribute, don't forget to distribute the negative, so you get positive 14x minus 42 equals 9. So we end up with 17x equals, add 42 to both sides, 51. Now divide by 17 and x is 3. So looking at our option choices, that only leaves us C. To make sure, we could plug it back in. 2 times 3 is 6, subtract 6 from both sides, y is 0. Okay, another way to do this without even solving, if you're given options like this, you can always take x and y and plug it into both equations, and remember, only the solution will make both equations true. Okay, this is the last one in this section. Sean and his sister have a combined weekly salary of $191. If Sean's weekly pay is 7 less than twice his sister's, which equation can be used to determine his sister's salary? Okay, so you have to read very carefully. First of all, Sean's salary is going to be 7 less than twice his sister's, so that's going to be 2x minus 7, where x is his sister. So his sister's is going to be 191 minus his salary gives you her salary. Okay, but they're not written like that. They're written as equal to 191. So you got to think, where would I be subtracting 2x minus 7 to get x by itself? And that would be D. So if we were going to solve for his sister's salary, we would move this whole salary over and get their combined salary minus her brother's salary to give you hers. Or again, because they're set up equal to their combined salary, you're adding their two salaries together. So that's another way to think about it. And that's it for this one.